Volcanic fury and ancient zircons unlock the moon's true age. And this is by the Max Planck Institute of Germany. The moon is far older than we once believed, but its fiery past has kept its true age hidden. New research reveals that a few 100 million years after its formation, the moon experienced such extreme volcanic activity that its entire crust melted and reformed multiple times, resetting its geologic clock. Back then, the moon orbited much closer to Earth, and the intense tidal forces from this proximity superheated its interior, fueling the violent eruptions. Only Io, Jupiter's moon, and the most volcanically active body in the solar system, offers a similar example of such extraordinary conditions. This fresh perspective, published in Nature by an international team from the University of California, Santa Cruz, the Max Planck Institute for Solar System Research and the Collège de France, resolves long-standing contradictions about the moon's age, and according to their findings, the moon was formed 4.43 to 4.15 billion years ago. However, its crust, reshaped by volcanic fury, appears at least 80 million years younger. Lunar age discrepancy. The moon has proven to be elusive when it comes to revealing its true age. Scientists' estimates vary by several hundred million years, with some proposing it formed 4.35 billion years ago, while others suggest 4.51 billion years ago. The inconsistency largely comes down to the rocks. Most lunar rock samples point to a younger age, but a few rare crystals of zirconium silicate, known as zircons, date much older. So how can this be? A new study offered the explanation. Researchers calculate that after the moon's formation, its crust was largely remelted. While most materials succumbed to these intense conditions, a handful of zircons remain intact, preserving a glimpse of the moon's earlier history. Unraveling lunar origins through collision. The history of the moon begins with a massive collision. In the early days of the solar system, a chunk about the size of Mars crashed into the still young Earth. The collision generated so much heat that our planet melted completely and hurled a huge amount of material into space. By and by, this material clumped together to form the moon, is the theory, initially covered by a huge ocean of hot, liquid rock. In the millions of years that followed, a newly formed body cooled and moved further and further away from Earth until it reached its current orbit at a distance of around 484,400 kilometers. I, for the life of me, don't understand how that's possible, how it kept on going away from Earth, because I would assume that the Earth would have had a gravitational pull on this. But anyway, going to this. Tidal forces and lunar heating. We are particularly interested in the phase when the distance between Earth and Moon was about a third of today's distance, explained Professor Dr. Francis Nemo from the University of California, Santa Cruz, first author of the study. At this time, there were various changes in the position and shape of the moon's orbit. Among other things, it became more elliptical, so that the speed of the moon and its distance from Earth varied noticeably within each orbit. The forces acting this way churned through the moon's interior to such an extent that it heated up. A similar situation is still known today from Jupiter's moon Io, which travels around the gas giant also in a slightly elliptical orbit. The enormous tidal forces of Jupiter make the small moon the most volcanically active body in the solar system. Earth's early moon was likely to match to Io. As the researchers' calculations show, the heat flow from the lunar interior was sufficient to melt and churn through the entire mantle, while at no time during this phase of magma ocean covered the entire moon. Over the course of several million years, the heat from the interior gradually reached every part of the surface, liquefying most of the crustal rock, possibly even several times. In some places, the hot lava penetrated to the surface. In others, magma was injected beneath the surface, heating the rocks around it. The impact of volcanic activity on lunar dating. This volcanic history is decisive for determining the age of the crustal rock. Since their formation, lunar rocks, like terrestrial rocks, contain radioactive isotopes. Isotopes are variations of certain atoms that differ only in the number of neutrons in the atomic nucleus. And as the isotopes decay, times are known, it's possible to deduce the age of the rock from their current concentration. The decisive factor, as long as the rock is hot, it can exchange isotopes with its surroundings, and when it cools, it locks in its composition. The trapped radioactive isotopes begin to decay, and the geologic clock starts ticking. The strong volcanism likely reset the moon's geologic clock, explains Professor Klein, director of the MPS and co-author of the study. Lunar rock samples therefore don't reveal their original age, but only when they were last strongly heated, he said. Only a few heat-resistant zircons provide evidence of the more distant past, the researchers show in their calculations. In some places where the lava did not reach the surface, the zircon grains remained cool so that their internal clock was not affected. The lunar rock samples tell us the moon's entire turbulent history. They tell us about its formation and its later violent volcanism. Until now, we just don't read these clues correctly, says Klein. And according to the researchers' results, the moon itself is between 4.43 to 4.51 billion years old. The violent volcanism shaped its crust around 4.35 billion years ago. The new findings also resolve many other contradictions that had previously puzzled scientists. For example, the comparatively few craters on the moon argued against its old age. In such a long time, our cosmic neighbor should have witnessed more impacts. Volcanism now offers an explanation. Lava from the moon's interior could have filled the early impact basins and thus made them unrecognizable, says co-author Professor Alessandro Mordibelli from Collège de France. The composition of the lunar mantle poses another puzzle for researchers. This is a layer of rock that lies directly beneath the moon's crust. Its list of ingredients differs from that of the Earth in key respects. However, if the moon's interior was molten a second time around, some substances could have escaped from the mantle into the iron core below. The new results mean that all the pieces of the puzzle that previously did not fit together now form a coherent overall picture of the moon's formation, says Klein. And for more on this paper, you can see Did Earth's Gravity Give the Moon a Volcanic Makeover? And this is from SciTech Daily by the Max Planck Institute for Solar System Research. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.